This will be the last integral problem you see in this room. And I only mean that for the year 2024 because in 2025, we're back with new content. But of course, don't forget that if TikTok does get banned, I'm gonna start posting a lot of my content on Instagram and YouTube, so make sure you follow me on there. Okay, so here we have the integral from 0 to infinity of e to the negative 2x sine of 3x all over x with respect to x. So we're gonna go ahead and solve this using the Feynman technique. So remember, the Feynman technique makes us create a function in respect to alpha. I like alpha. Some people use t, some people use other variables, but I personally prefer alpha. And you create an integral where your alpha goes somewhere in here. Typically it replaces one of the constants. You can probably replace the 3, but I'm gonna replace the 2 there. So this is gonna be e to the negative alpha x sine of 3x over x with respect to x. Okay, and before we do this, before we even start taking the partial derivative with respect to alpha, we need to find some condition. If we have I to the infinity, then we're gonna have integral from 0 to infinity of e to the, now we're gonna make that infinity, so we have negative infinity x sine of 3x over x. Check out what's gonna happen here. Because that's a negative infinity, it's gonna go on the bottom. So you're gonna have infinity in your denominator, which is gonna send this whole thing to 0. So now we have this condition that I to infinity is equal to 0. We're definitely gonna revisit this later on. Okay, so now we're gonna go ahead and take our partial derivative with respect to alpha. On the left side, we just get I prime of alpha equals, and then over here, all you have to do, since we're taking the partial derivative with respect to alpha, is treat every x variable as a constant because we're not differentiating with respect to x. We're only worried about the alpha. So we're really just gonna take the derivative of this and then multiply this entire thing. When you take the derivative of this with respect to alpha, you're gonna get 0 to infinity of negative x e to the negative alpha x sine of 3x over x dx. Definitely practice with that because again, a is the variable, x is the constant. So if this was like 2x, 2x, and it will be, or 2 alpha, I guess you can say, then the derivative will be negative 2 on this case. Okay, so the reason why we did this is so that these x's can cancel out, so this negative can go on the outside. So we have I prime of alpha, negative 0 to infinity of e to the negative alpha x sine of 3x dx. Okay, so this is where we're gonna go ahead and bring our Euler formula to talk about that sine 3x. Okay, so here is our Euler formula where theta is the argument. So now we're gonna change that theta into negative 3x. So we plug in negative 3x for every argument for the cosines and sines. Cosine is even, so that just becomes cosine 3x. Sine is odd, so that negative can come on the outside. And now we have negative I sine 3x. So because this is basically what we wanna worry about because that's exactly what's in here, we just want the imaginary part of e to the negative 3ix, and that's gonna